Okay, we're going to expand this expression to be a sum and or difference of logarithms. So we're going to expand it, and sometimes I go a little crazy when I expand because I love being able to use prime factoring and my knowledge of exponents to take this as far as I can take it. So sometimes I go a little bit too far, and it's okay for you to go a little bit too far when we're expanding these. We just want to make sure that you've got a real good understanding. Sometimes the book is not going to go as far, but if you can do it as in depth as I'm doing it, then when you look at your answer, you're going to be real good. Okay, so we've got log base 6 of 7 times 9. I'm just going to go backwards. I'm going to expand this. So this right here is the product rule. So I have a product, and that product is going to become expanded, right? So we're going to expand it. Each factor of the product is going to become its own argument. So I've got log base 6 of 7. There's no denominator, so these are both going to be positive logarithms. Log base 6 of 9. Now this is what I'm talking about. In the back of the book, it would not surprise me if that was the answer. However, once you start studying those exponents, you know, the 1 squared through 25 squared, the 1 cubed through 10 cubed, the 1 to the 4th through 5 to the 4th, the 1 to the 5th through 4 to the 5th. Once you start studying those, you start seeing numbers in such a cool way. For instance, would you ever have thought that this would be the answer? Would you ever have thought that would have been the answer? Log base 6 of 7 plus 2 log base 3 of 3. And then you go, wow, log base 3 of 3, log base 3 of 3. It shouldn't be log base 3 of 3. We made a mistake. That should be log base 6 of 3. And you go, ah, that's so much better. So much better. There we go. I don't know what I was thinking there. But sure, so this right here could be an answer. So this has prime arguments. Prime arguments. This does not have prime arguments. So it all depends on the textbook publisher and what they're looking for. Either one of these is correct, but this right here is a fantastic answer. Fantastic. Okay, let's try another. We've got log base 9 of 15 over 7. Log base 9 of 15 over 7. This is the quotient rule. Quotient rule. So we're going to have a positive logarithm and a negative logarithm. So we're going to have log base 9 of 15, that's our positive logarithm because 15 is in the numerator, minus log base 9 of 7 because 7 is in the denominator. I have that negative logarithm. 15 is not prime though. 15 is not prime. So we're going to take this a step further. It's 3 times 5. So that would become log base 9 of 3 plus log base 9 of 5 minus log base 9 of 7. Now we could have seen this a little earlier had we rewritten before we started 15 to be 3 times 5 over 7. Now I like to use highlighters here. I've got a factor, and a factor. I count the number of factors I have, and that tells me how many logarithms I'm going to have. This is 3 factors in the argument equals 3 terms. We end up with 3 terms. Now log base 9 of 3, log base 9 of 3 is 1/2. So do you see how cool this really becomes? Would not surprise me if this were an answer in the back of the textbook. However, this right here is a great answer, most especially when it says simplify. It says expand the expression to be a sum or difference. So this could be a publisher's answer. So this could be a publisher's answer, because I think that they might just be wanting you to make sure that you can expand and not going too far in depth. This is an excellent simplify. So this is an excellent simplify, because that log base 9 of 3 you should recognize to be 1/2. Okay, so let's do that highlighting thing again. I really like the highlighting thing. We've got log base A of m n q in the numerator over p squared. So I'm going to need 4 highlighters, m, n, q, and then we're going to need p squared. So that means 4 factors, 4 terms. We'll have log base A of m, that's going to be positive because m is in the numerator, plus log base A of n, is going to, it's in the numerator, so it's going to be an argument of a positive logarithm, and q is also an argument of a positive logarithm. However, p squared is not. So p squared is in the denominator, so that's going to be minus log base A of p squared. And you might have caught on so quickly saying, wait a second, that exponent needs to go out front. And you would be indeed correct. Log base A of m plus log base A of n plus log base A of q minus 2 log base A of p. With practice, you'll be going straight from the first problem all the way to the answer. And I think we're going to practice that right here. We've got log base A of the cubed root of m squared. There's not really much to this, is there? So you might want to press pause and try it and say, I think I can do this. I think I can do it. I think you can do it too. If you tried it and you're coming back, here we go. We've got m raised to the 2/3 power. Now that 2/3 is going to go out front and become a factor. So I've got 2/3 times log base A of m. And that's all that we can do with that one. Nothing else that we can do there. How many terms would we have after expanding this? How many terms are we going to have? This is another great example for you to try. So go ahead and try this one and then come on back. The answer is we're going to have 3 terms. 3 terms. I'm going to first rewrite this, getting rid of the radical, just like I did on the last one. So just like I did here, I made the radical a rational exponent. I'm going to do the same thing here. So this is going to be x cubed y to the 5th over z squared, all raised to the 1/7 power. So I can look at this as a 1/7 power, which means natural log of x to the 3/7, y to the 5/7, z to the 2/7. And I'm going to have 3 logarithms. I'm going to have 3/7 times the natural log of x plus, because y is in the numerator, 5/7 times the natural log of y minus, because z is in the denominator, 2/7 times the natural log of z. And that is our final answer. That is our final answer. Okay, we're going to have a little bit more fun with some more exponents. So we've got a couple more of these problems where we're expanding, just to give you a variety of examples to have seen. And then we're well on our way. We're well on our way to getting closer to the end.